Hello, this is Python and Deep Learning ICP-5 Assignment. We have two datasets we are using in this assignment. First one is the Titanic dataset and the second one is the glass dataset. For the first question, we need to implement a naive Bayes and find the accuracy, and we need to do two visualizations to describe and show the correlation between the variables, and we need to find the correlation between surveyed, which is the target column, and the sixth column for the Titanic dataset, and we need to see if we want to retain these features in our model or not. Coming to the first question, I have imported pandas, seaborn, matplotlib, and naive Bayes from scikit-learn. I have imported these libraries and I have used the pre-processed test and train datasets, and as you can see here, I have dropped the survived, which is the target column, and stored the other features in the train x underscore train, and in the y underscore train I have excluded all of the features and have stored only the target column. And here, as you can see, I have called the naive Bayes classifier, and I've created an object here, and I have used xtrain and ytrain dataset to train this classifier, and used .predict method of naive Bayes from the scikit-learn to predict the new values of x test. And as you can see here, I have used the score function to find the accuracy of this model and have printed the accuracy. As you can see here, we got the accuracy of 77.67 for the naive Bayes classifier. And here I have used the seaborn heat map feature function to see the correlation between the surveyed and the six features of the dataset. Here you can see they have 0.54 of correlation between them, which is moderately good. So we can say that these two features are correlated moderately with each other. And then coming to the first visualization, I have plotted the correlation matrix of all the variables. If you want to check here, if you want to see the correlation between survived and the sixth column of the dataset, here you can see 0.54 as we have here. And if you want to see the correlation between fair and embarked, here you have 0.062, which is very less. So we can say that these two features of the dataset are not well correlated with each other. One being the highly correlated, and minus 0.4, less than minus 0.4 is not very correlated. And then here you can see I have printed the values over here. So here you can see the 6 and the survived has 0.54 correlation between them. And here I have printed all the correlation matrix between all the variables in the data. Here also you can check for the survived and the 6 we have 0.54 correlation between them. Here I have used another method of seaborn to plot the correlation matrix in a different way. Here the correlation being very high if it is above 0.4 and very low if it has if it is below minus 0.4. Here you can see the black color between the fair and P class, which is in the black color, from which we can say that these two features of the dataset are not well correlated. And coming to the second question, we need to use the glass dataset, and we need to import time test split to split the training data and the test data, and use the score function to find the accuracy of the model. And we also need to use the classification report to see the classification report of the model, and we also need to show two visualizations to describe the correlation in the glass dataset, and we also need to describe which algorithm is better according to the accuracy of the models. Coming to the second question, as you can see here, I have imported the required libraries and have imported class.csv using pandas and I stored it in the dataset variable. And for the x values, I have stored all the features except the last type column. And coming to the y variable, I have stored only the type variable, the last column, the target column, into the y variable. And here, as you can see, I have used try test split on x and y. So in order to get x try, x test, y try and y test, here I have used random state as 0 and I have also used test size as 0.25. So here, for an example, if you have 100 rows, if you take test size as 0.25, we will have a test data of 25 rows and the train data of 75 rows for the dataset which have 100 rows in it. This is just for an example. And here I have used standard scalar from scikit-learn for feature scaling so that we can run this algorithm even faster, so that all the data in this dataset is scaled. And here I have imported svc library from sklearn and I have created object of classifier and used kernel is equal to linear as shown here. We need to implement linear svm method. Here I have used the random state as 0 and I have used x train and y train data to train this model, and I have predicted using .predict method on x test to get the y pred values. Here I have also printed the confusion matrix which is imported from scikit-learn. Here as you can see, I have imported confusion matrix from scikit-learn, and here I have imported classification underscore report from scikit-learn as shown here to get the classification report. And here at last you can see I have used the score function to find the accuracies of the train and test data. So here you can see we got an accuracy of 0.61 for the algorithm SVM, linear SVM. And with the second part, I have imported the required libraries, stored the data set, and I have split the data into training data and testing data using time test split, and used test size as 0.25 with a random state 0, and I have used standard scalar for feature scaling as shown above. And here as you can see, for a change, here I have used naive Bayes classifier, not an SVM classifier, and here I have imported Gaussian NB from naive Bayes and created object of it and trained the model on x underscore train and y underscore train data, and have predicted the test y pred values using x test data. And as you can see here, I also printed the confusion matrix. And here I have imported classification underscore report from scikit-learn and have printed the classification report as you can see below. And here I have used the score function to find the accuracy for train data and test data for naive Bayes. If you compare these two models, the first one being the SVM and the second one being the linear SVM and the second one being the naive Bayes. For SVM I have 0.61 accuracy, and for naive Bayes I have 0.46 accuracy for the GLASS dataset. So when we compare these two datasets, we can say that SVM is better, fits the data than the naive Bayes. And here to show the visualization, I have used heat map of Seaborn library to find the correlation between each and every variable. As you can see here, if you want to find the correlation between K and CA, here you can see we have correlation of minus 0.32. As you can see here, we have minus 0.32 is very less correlation between, we can say that there is very less correlation between these two features, one being very good correlation and less than minus 0.6 is very bad correlation between the features. And here I have used pair plot or Seaborn library to show the correlation, to plot the correlation matrix. As you can see here, if you can see, we can say that this variable and this variable are highly correlated. As from seeing the graph, we can say that there is a positive correlation between these two variables. And here you can see that there is a negative correlation between this feature and this feature. And coming to the last visualization, I have used another method of heat map of Seaborn library to plot this correlation matrix diagram. This is the same diagram in a different way. As you can see here, if you want to find the correlation between type and NA, here you can see the correlation is in this range. We can say it as 0.5, and we can say that it is these two features are moderately correlated. Here, as you can see, 0.8 is highly correlated, and the black color over here, which is less than minus 0.6, is not correlated in a good way. So we can find the correlation between two variables in this way. And at last, coming to the classification report, here as you can see, I have printed the confusion matrix. Here, coming to the classification report, here we have precision, recall, F1 score, and support. And coming to the support is the number of samples each metric was calculated on. And coming to the precision, what precision indicates is that it indicates the proportion of positive identifications which were actually correct, and the model which produces no false positive has a precision of 1. So here we got precision of 0.32 with 14 samples. And here what is recall indicates the proportion of actual positives which were correctly classified. A model which produces no false negatives has a recall of 1. As you can see here, for the 7 samples we have precision, recall, and F1 score as 1. And what is F1 score? F1 score is the combination of precision and recall. A perfect model achieves an F1 score of 1, as you can see here with the 7 samples, but here we have 0.43 as an F1 score for 14 samples. And here, what is the support? Support is the number of samples each metric was calculated on. This is the end of ICP-5 assignment. Thank you.